Hello and welcome to T Academy. In today's lecture, we'll be introducing phasors. So, phasors are a way of representing complex numbers. And complex numbers can be represented either in the Cartesian form or in the polar form. In the Cartesian form, a complex number can be written as a plus j times b, where a is the real part of the complex number and j times b is the imaginary part. While in the polar form, a complex number can be written as x angle theta, where x is the magnitude and theta is the phase of the complex number. Now this can be explained with the help of an Argand diagram. If a is the real part of the complex number and j times b is the imaginary part, then in the Cartesian domain this can be represented by two vectors which are perpendicular to each other. So j times b will be leading a with an angle of 90 degrees. Now it is possible to go back and forth between the Cartesian domain and the polar domain. Now if a is the base and j times b is the height, then the magnitude x is the hypotenuse and the angle that this vector x makes with the base is the phase theta. Now from this diagram we can see that the magnitude x is simply equal to a square plus b square whole square root according to the Pythagoras theorem, and we can write tan theta equal to perpendicular over base, and theta from here can be found out as tan inverse b over a. So using these relations, we can go from the Cartesian domain to the polar domain. Now it is also possible to go from the polar domain to the Cartesian domain. So we see that the projection of the vector x onto the base is equal to x times cosine of theta, and the projection onto the perpendicular is equal to x times sine of theta. Therefore we can write the real part a is equal to x times cosine of theta, and the imaginary part b can be written as x times sine of theta. So these two relations allow us to go from the polar domain back to the Cartesian domain. Now let's see how we can use these relations to perform basic operations on complex numbers. Now let's work out an example. We have this equation 3 minus j7 plus 4 angle 31, and we need to find out the final solution. Now seeing this, we immediately recognize that this first part of the equation is given in the Cartesian domain, and this second part 4 angle 31 is given in the polar form. Now we need to make the coordinate system identical in order to perform operations like addition and subtraction. Now in order to go from the polar domain back to the Cartesian domain, we just saw in the previous slide that we can write A is equal to x times cosine of theta, and B can be calculated as 4 times sine of theta. This comes out as 3.43 and this comes out as 2. Therefore, 4 angle 31 in the Cartesian domain can be written as 3.43 plus j times 2. Now substituting this value back into this equation, we can write the whole equation as 3 minus j7 plus 3.43 plus j times 2, which equals 6.43 minus j times 5. Now this is the solution in the Cartesian domain. Now if we want to convert it back into the polar form, we can find out the magnitude x as 6.43 square plus 5 square whole square root, and the angle theta as tan inverse of minus 5 over 6.43, and this gives x as 8.14 and the value of theta comes out as minus 37 degrees. Therefore, the solution in the polar form is equal to 8.14 angle minus 37 degrees. Now let's see how we can represent this solution with the help of phasors on an Argand diagram. Now we saw our solutions in the Cartesian domain as 6.43 minus j5 and in the polar form as 8.14 angle minus 37 degrees. So 6.43 will be along the real axis and minus j times 5 will be along the imaginary axis in the negative direction. So this is minus j5 and this is 6.43, and the magnitude phasor will be along the direction of the hypotenuse. So this magnitude will be 8.14 and the angle that it makes with the base is minus 37 degree. So this is the solution with the help of an Argand diagram. In the next lecture, we will see how we can use the concept of phasors to simplify AC circuit analysis. So that's all for today, and see you in the next lecture.